So if we look at these problems, A through E, you'll see that there are problems where we're looking at side lengths, problems where we're looking at diagonals, problems where we're looking at angles. And those kinds, and you kind of need to think about what properties are going to come into play. Because I can tell you this. Let's just look at A. This is one of the easy problems on the page. And what you're going to typically have when you think about what to expect on your test is you're going to have a problem that looks very similar to this. And I'm going to give you an x and a y that you need to solve for. Or x and perimeter, or something like that. You're going to have to solve for two different values. And in this case, we're looking at this and we need to think, okay, am I looking at sides, angles, or diagonals in this problem? What is it? Sides. For A, it's just sides of the parallelogram. I don't know anything about the angles, I don't care. I don't know anything about the diagonals, and I don't care. So the only thing that matters are the side properties. And this one's an easy one. So we only have two side properties. Let's go back to that and see what they are. So you're looking at this, and like I mentioned yesterday, you're going to have this available, all the properties. So right here, opposite sides are parallel, opposite sides are congruent. What's going to matter for this problem? Opposite sides are congruent. So this is why it's an easy problem. If opposite sides are congruent, what's the value for x? 12. No calculation required. Now, if you don't know that about parallelograms, there's no way of solving for it. If you know it, then it's super easy. All right. Now we need to solve for the perimeter of this parallelogram. So what do we do there? Add all of them up. I've got 12, 19, and 12. What's that? 19. Add all that up. There it is. When you add all that up, you should get 62 centimeters. Okay, so is it... I mean, obviously that's not a difficult problem right there compared to some of the other ones, but does it make any sense? All right, so the next problem. Actually, let's jump to C. B is a pretty easy one, but you guys can figure it out in a minute. So C gets a little more complicated. We're solving for x and y. Are we doing with sides, angles, or diagonals? Angles. There it is. And, you know, you can't have problems where there's kind of a mix, where it's not just angles, but it's also diagonals or sides and diagonals. So it can be more than one, but you just kind of have to ask yourself that question at the beginning. So for problem C, we've got angles is what we're looking at. So the only angle properties we have, we just mentioned them. So what's one of them? Okay, let's not do this. What are the angle properties? Say that again. Opposite angles are congruent. All right, everyone say that. I need everyone to wake up. Opposite angles are congruent.
Opposite angles are congruent.
There you go. I need everyone to be aware that those words mean things. Okay? Opposite angles in parallelograms are congruent. So you need to know that. How can we use that in this problem? C. Y is going to equal 50. These two angles are opposite. And that means they are congruent to each other. And you will typically have a problem set up where one of them is easier to find than the other. So I'll tell you right now, and I'll try and mention this more times. Sometimes what happens is people will find correct answers, but they'll flip them as far as the answer blanks go. So they'll know that y is 50, but they'll accidentally put it for x. And you can lose credit for doing that. So make sure you're putting it in the correct blank. All right, so now we need to solve for x, and what are we going to do with this one? Okay, what are we going to add up? 18 and 50, so I'll do this, so 18, 50, and what else?
Times 2? No. You're adding all that, and then I'll add 180.
Okay.
You have to get something.
Okay, so let's just kind of, and maybe this is, I'm hearing a lot of voices, so let's just kind of say this. So these two angles right here, and it doesn't matter which consecutive angles I'm talking about, these two angles or these two angles, remember that's 50 also, so it doesn't really matter. But these are consecutive angles, these are consecutive angles. If I add these up, it should add up to, like Brandon was saying, add it up to 180. Because consecutive angles are supplementary here. So, of course, that first angle on the left, bottom left, is going to be x plus 18. So that'll be that angle right there. And then plus 50 will be the other angle. And these have to add up to 180. So we have the equation. You guys should be solving that equation now. You don't need to wait on me for that. And what does x equal? 112 degrees. All right. So I'm not trying to go too fast. I know for some people it might be a little fast here. The important thing right now is that you're understanding how we're getting these equations. If that's making sense, then solving the equations, if it takes you a little longer to do that, not a problem. But if you don't know how we're getting the equation, then that does become a problem. You're not going to be able to get the answer at all that way. So are there any questions on why we set it up as x plus 18 plus 50 equals 180? Okay. So I just wanted to look at one more of these, and then we'll just kind of get another one set up. We're not going to solve it, but we're just going to look at it real quick. Okay, so let's look at D real quick. So the question on this one is sides, angles, or diagonals. What are we looking at for D? Yeah. So in this one, we are looking at diagonals. There's no side information. There's no angle information. This is just very purely a question about diagonals. We only have one diagonal property. What is it? Yeah, the diagonals bisect each other. So this point in the middle, it's not labeled, but this point in the middle, if you want to call it point E or something, is the midpoint for this diagonal and for the shorter diagonal. So it's a really straightforward problem, as long as you understand that. So let's look at this real quick. AC, we're trying to find the distance from A to C. What is it going to be? 18. So if we know one of these sides is 9, this is going to be 9 centimeters also. And therefore we get our 18 centimeters. And what is the distance from B to D going to be? 6. Same thought process. If we've got 3 centimeters on one side, we're going to have 3 centimeters on the other. And we have a total of 6 centimeters. Really simple problem here. This one might be the easiest one on the page. But again, if you don't know that diagonals bisect each other, then it's impossible to do. If you do know it, it's the simplest calculation possible. Okay. So I'll leave the other two right there. I know it's not a lot for you guys to practice with, but we're going to get more practice with this later. We're also going to look right here at problem G. Okay, problem G definitely looks a little more complicated. but it's really not too bad. And I bet a lot of you can already figure out how you'd approach solving this, but I just wanted to walk through the first part of it at least. What do we know? Well, I guess we'll start this way. Sides, angles, or diagonals? What are we looking at? Sides. So what do we know about sides of parallelograms? Opposite sides are parallel, opposite sides are congruent. All right. So if opposite sides are congruent, what can we do with that? I'm going to mark these sides as congruent real quick. There it is. So if we know the opposite sides are congruent, we can set up some equations. 3x minus 5 equals x plus 25. I'm just going to write it as x. We don't need the 1x in front of it. Okay, can we set up any other equations? There it is. 4x equals 2y minus 12. All right. So you guys can do it from there. Solve for x, solve for y, solve for the perimeter by plugging those numbers back in. Again, if you have questions on that and you don't know what to do to proceed, let me know. But anyways, I'll give you guys a few minutes to look at this, but I wanted to move ahead to rectangles here in a minute. So just take a few minutes to look at this, try and process what we talked about so far. And let's start looking at another set of properties. There's only 2 triangles to rotate this time. I don't want to spend time with this, so we're just going to rotate it really quick. When you do the rotation, your points will end up right here. And keep in mind, as you are creating these quadrilaterals, and these are rectangles, I'm going to go ahead and write that in. So as you're creating these quadrilaterals, what you're doing is you're rotating a congruent triangle. So that means that the opposite sides will be congruent. All right, because I'm just rotating the same triangle and everything should be the same. All right, does that make sense? So you can see kind of what I've done here. It's just copied all the symbols over. All right, and that's going to help us when we're thinking about our properties. We're going to go through the side, angle, and diagonal properties of rectangles now. And the first one, are the opposite sides parallel? Yes. Yes, they are. Now it's really easy to see in this bottom one because the 2 sides are perfectly horizontal and perfectly vertical. So really easy. But remember, and you do need to remember this idea, the slopes have to be the same. So if we look at the first one, the slope on the top is what? The slope there is what? Up to over to the right, we should say 4. All right. And then that simplifies down to 1 over 2. And what about at the bottom? So right here, what is it? Okay, and you can think of it as down 2, left 4, which when the negatives cancel each other out, it's still a 1 over 2 slope. So whether you think of it as down 2, left 4, or up 2, right 4, you've got your slope, and you're in good shape. All right, let's do the same thing for the other side. So what is the slope right here? Down 2, right 1, which gives us a number of -2 over 1. The negative 2 is the down 2. And the 1 is right 1. Is it the same on the other side?
Yes.
Yeah, it is. So negative 2 over 1. All right, so the opposite sides are parallel. Again, we knew that to begin with. I should mention right now that rectangles are parallelograms. These are going to have all the properties of parallelograms, but they're going to have their own properties as well. So if you want to do a shortcut, you can kind of check off all the same properties that you had for parallelogram and just be prepared to add some others. But I'll just leave them unchecked for now. Okay, opposite sides are congruent. True or false?
True.
That is true. That's a parallelogram property, so it's going to be a rectangle property also. Adjacent sides are perpendicular. That one is also true. Now, again, an idea that if you know it's a rectangle, you don't need to worry about this. But it is something that I want you to be aware of. You've got two slopes on the adjacent sides. 1/2 and negative 2 over 1. We talked about the idea that perpendicular lines are negative reciprocals. And what we need to think about is, do I just flip the fraction of one and get it and make it negative, and will it equal the other? So 1/2, if I flip it, make it negative, do I get the slope of the other line? Yeah. So 1/2, if I flip it, becomes 2 over 1. If I make it negative, it's negative 2 over 1. So let me kind of show that real quick. 1/2, I'll flip it to give me 2 over 1, and I'll change the sign of it to give me negative 2 over 1. And sure enough, those are my two slopes. Now, another test that you can use here is multiplying those two slopes together. So let me do that real quick. I've got 1/2 times negative 2 over 1. And when I multiply that out, I'm going to get negative 2 over 2, right? And that simplifies down to what? Negative 2 over 2 is the same as? Yeah, and I'll just say, in this case, negative 1. So this is the other thing. This is maybe the fastest way of doing it. Take your two slopes. If you have two lines, take the two slopes, multiply them together. If you get negative 1 as your product, then you have perpendicular lines. Okay? All right, and I will give you more practice with that because I will include it on the test, that idea. All right, but we can move past that for now. Next property, are all four sides congruent? No. Angles. Are opposite angles congruent?
Yes.
Yes. Are consecutive angles supplementary?
Yeah.
Yes. And remember, those are parallelogram properties, so it's going to be true for a rectangle. Now, are all four angles congruent?
Yes.
Yes, they are. They're all 90.
Because it's straight, that's why 90 degrees.
That's right. All of them are 90 degrees. And the only way you're going to get four congruent angles is if they're all 90 degrees. Okay, and then the diagonals. This is going to be the newest part of it, something you probably haven't explored before. But diagonals, do they bisect each other? Yes. Yeah, we know that's true because it's a parallelogram. I'm going to go ahead and draw in the other diagonals so that we can kind of explore that a little bit more. Okay, are these diagonals that are drawn in, are they congruent? Yes, they are. Are the diagonals perpendicular to each other? So another way of asking is, do they intersect at 90 degrees?
Oh, no.
No, they do not. And do the diagonals bisect their angles?
Yes. Yeah.
It's not true in this case. That is not. They are not angle bisectors. Let me draw in what an angle bisector would look like. This is a 90-degree angle, so if I draw an angle bisector, it's going to come down at a 45-degree angle like that. that I just drew in purple. This is an angle bisector. There's your diagonal. So it is not an angle bisector. Okay. So those are our diagonal properties. And these are now, this is a set of properties for a rectangle. It's unique to the rectangle. When we study the rhombus and the square, we'll see different sets of properties. Okay, and I just want to run through one problem real quick. And it won't be real quick, but I just wanted to run through one problem with the rectangles and give you time for the rest of class to practice with these. So we're going to have to use different properties here. And the one I wanted to do is E because that one's this one requires using Pythagorean theorem. You guys have all seen it before. How many of you remember the Pythagorean theorem? Okay. Can anyone tell me what the Pythagorean theorem is? A squared plus B squared equals C squared. I'm going to run through this one with you because we're going to be using the Pythagorean theorem a lot next semester, and you'll get a lot of practice using it. But for now, it might be something that you haven't used in a couple of years, and so you've forgotten. So if we're looking at E, are we looking at sides, angles, or diagonals, or a mix? Okay. A mix between what? Sides and diagonals. You can see we've got information on the sides, but we're solving for some distance on the diagonal. And so we got kind of a mix of sides and diagonals. One of these is easy to solve for. What can we find pretty quickly? What is y going to be? 3. We know opposite sides are congruent. So yeah, y is an easy one. So x is the one that's a little more challenging. So what I want to do is I want to draw this diagonal right here from F to H. I'm going to draw that separately. I'm going to try and make it look about the same. And then this length from H to I, I'm going to draw that over here. And then F to I, I'm going to draw that one in also. So I basically just recreated this triangle right here over here. And there's a couple of distances I already know. I know that this is 3 centimeters. This is 4 centimeters. And this hypotenuse right here, remember this is a right angle. This hypotenuse is, I'm just going to call it C for now. Let's not worry about the X. We're just going to call it C. So we have to use our Pythagorean theorem to figure out what that hypotenuse is. I'm not going to include a question like this on the test, but it is worthwhile to go through it right now so you can get some practice with Pythagorean theorem and so that you can get some practice with the properties of the rectangle. Okay, so how would we set up our Pythagorean theorem equation in this case? 3 squared plus 4 squared equals C squared. And I will spend a full day, we'll go over this in great detail, but you have the short leg squared plus the long leg squared equals the hypotenuse squared. And now we can kind of go through and solve this. 3 squared, what is that? 9. Remember 3 squared is just 3 times 3. That's all I was telling you. So you get 9. 4 squared, 16 equals C squared. What's 9 plus 16? 25. And what do we do if we have C squared and we just want C? The square root, which looks like that. Luckily, this is one we get a nice round answer. What is C going to equal? 5. The square root of 25 is just 5. Because think 5 times 5 is 25. So that's why the answer is 5. Okay. So we now know that the entire length from here to the other side is 5. Everyone with me on this logic? Okay, so what is x going to equal? 2.5, 2.5, however you want to phrase that. You can even call it 5 halves. I'm fine with any way you want to write this number down, as long as it's a correct form of it. Okay, so at this point you have a little over 10 minutes. This is the only one that requires Pythagorean theorem. The rest of them you can do with just other methods that you're more comfortable with. So try this, and I've got an answer key at the front for anyone who wants to check their work along the way.